My name is Naveen. I work for Charter as a senior director. A lot of what I want to talk about is, I think this morning we had an architecture talk about like how does an architect approach this? How do you approach this if you're building new stuff? We have a slightly different take on it. I work for an enterprise company. In case you haven't heard, it's a Fortune 100 company. Comes with a lot of thou shalt not do this, then what can you do, right? So it's how do you enable developers in an enterprise? I think that's some of our challenge that we face. I think if you work for a small startup, which I have, I've worked in startup of 10 people, you don't really face that because it's a lot of you do what you need to do because you're going to do the right thing. So a little bit of background, about 4 years ago when I first started on this process, I would say Charter didn't have a homegrown software engineering team. Everything was basically outsourced to any vendor, like including the portal itself. So if you're a customer, you want to pay your bill, you logged into a site, that wasn't even actually maintained by Charter. It was driven out of a third-party vendor. So that gives you an idea how little of a software engineering footprint we had. So generally speaking, we built one monolith on VMware about 4.5 years ago just to give it a try, see how it looks. That was our first app. Out of that came about 9 or 10 philosophy or guiding principles for us. We learned quite a bit by running on VMware. Things go down, load balancers don't like you. You wake up in the middle of the night to see that somebody's trying to watch Game of Thrones. That's my favorite because Game of Thrones on iPads is quite popular. We didn't build it to scale. Nobody knew that. Monday Night Football crashed our app because Monday Night Football, people are outside, they're traveling, they still want to log into their app and watch Monday Night Football. So 4.5 years ago, you find out one Monday, it doesn't go well when you built it for 5,000 concurrency because it's your first app, and you got about 50,000 people logging in. So yeah, things you learn when you run in production. So out of it, we basically talked about how can we make this easier? Try to make it cloud. We picked AWS about 4.5 years ago, native. Worked out pretty well for us. We do have some concerns. I think we're going to be cloud neutral. I think that's the new term, or cloud agnostic. Internally, that's a big push because nobody seems to trust Amazon. That's my answer today. But microservices mostly because it was an easier answer back then than saying monolith. I think everybody kind of knew there was pain there. There's a whole bunch of stuff which most people will realize if you're going to design a new app from scratch today, you would do auto-scaling, you would do multi-zone. DevOps is a philosophy, CI/CD. There's a bunch of stuff around CI/CD that I'll touch from SmartBear, how we actually use SmartBear, what products we've used them for specifically. And then there's zero downtime deployments, which in an enterprise company, you'd be surprised how much they go, did you just deploy in production? We're like, yeah, it's production, it's fine. And they're not like, oh, that doesn't sound right. So that's, generally speaking, those were the guidelines that we came up, we agreed to, and we said, how do you help build something that scales? So from a design philosophy, we picked up Netflix OSS running on top of Amazon about 4 years ago. When you look at it, I think the picture on the right is just a picture of how Netflix, I think, open sourced some of their stuff. What we realized after running with Netflix for about 2.5, 3 years is Netflix is great at open sourcing stuff, but they're not open sourcing their secret sauce. There's a lot more that goes behind. And you realize that on day 2, but you're too far in, and you start building tooling around it. But it's a question of what's enough and what's actually your core business. So that's one of the challenges we typically seem to struggle with. But generally speaking, a great platform. They've done a great job, obviously, open sourcing some of the best components. We wrote our own middle configurations on how you store them between development, all the different environments before you go to production. Again, another philosophy problem which you find in enterprise, which is you can't run everything in production. There is no concept of A/B in production. People don't appreciate it as much. You want to do a dev. You want to have at least some sort of a pre-prod. Then you put it in production, which usually means longer test cycles, longer, generally speaking, what I consider time to market. Because product, even in an enterprise company, has realized they need to push faster. So they're asking for 6 weeks turnaround. but your test cycles are still stuck at like about 3 to 4 weeks. So where's your automation? How can I help you? So generally speaking, what you end up hearing, I think in a size of our company for the speed our product's moving at is shift left. How can development bake stuff in so when it goes out of the door, it's actually built in? So from that aspect, when we decided we had a fresh start, we looked at code deployment. How do you do code deployment? How do you do configuration? Especially in production, where we're thinking of running everything we build from a software engineering perspective touches any customer we have. So we have about 22 million subscribers, I want to say, today. So the number 2 largest cable company. Anything you touch is going to be in production. It could make news, let's put it that way, right? So generally, that's a bad idea when you make news in our company. I think there's good ways you can make too, but generally, if you notice why you made the news, it's not good. I think last week there was a security breach and Charter made the news because of Time Warner Cable. So Time Warner Cable is a company that Charter acquired about 1.5 years, 2 years ago, I think. So you don't make the news for good reasons. Cable goes out, it makes news. If customers are not able to record something, they're not able to watch Game of Thrones, it'll make news. So a lot of this is built around how do we help operations deploy stuff. Even though we have a philosophy of DevOps, we technically still don't actually own or operate operations. It's run as a separate silo in an enterprise company, which is, it's okay, it works for us. But it has its challenges because you have people who are willing to work with you, but it still faces challenges. How do you work with them? How do you make sure when they deploy something, they understand what they're deploying, where the challenges are coming from? So this is a pretty massive picture. I'll give it about 2 seconds for folks to take a look at it, and I'll explain to the actual context. I don't know if you can read. I think it may be a little bit small for this. So the way we designed our continuous integration was we'll go with everything on the left as essentially stash. Code is everything. You commit code to the actual dev jobs. They go through the top line, which is how do you make sure your development is actually still kosher? So about 4 years ago when we looked, I think somebody was using SOAP UI on a desktop. We kind of took that, put it on steroids essentially. We baked it into Jenkins. We stood up a server that basically goes and gets a license every time. It's a floating license concept. It basically checks it out, checks it back in. Turns out it's not as easy because we were running on all Amazon. We only do Linux. We obviously don't have Windows boxes. And thanks to Mike, who's in the back, he found me a developer like in Sweden in 4 days, which I was very surprised because I wasn't expecting that speed. So from that aspect, it works really well. So all of the groovy scripting that the testers are writing essentially is baked into SOAP UI, and it runs continuously. One of the things we saw after is, so great, you're running all these test cases. Jenkins is kind of ephemeral for us. Jenkins lasts about 100 jobs, which for us is about 2 days, literally speaking. The number of developers, the scale at which we're running, the data is basically getting lost, essentially. Like developers are not sure how they're doing build over build from a job perspective, and if there's anything they can learn from this. So we built a Cassandra box, highly tuned for some of this stuff, like how do you write tests? What does it mean when you write them? Took us about 6 months to solve this problem, I'd say, and then after that, we have quite a bit of what I call test data. And this is one of my usual jokes, which is like, if somebody were to build this, we'd pay them, but nobody's building it. So we basically wrote our own, essentially, in that sense. So, and you notice in the top picture, there's something called CI DevOps tool. It's essentially like a tool that helps you manage and understand how your dev builds are doing over some time. Generally speaking, the way we look at it is the top is development. This is more of the what I call engineering lab. How do you run in pre-prod at the size and the scale? From a Netflix OSS perspective, there's stuff like Asgard, Eureka, which are pretty good from a service discovery, service monitoring perspective. And then on the right side, we consider that our production. So our goal was primarily to take all the dev test cases we write and extend that into production. So some of the challenges we saw on the version 1 didn't really extend to version 2.0 or 1.5. The version 1.5 was more around, folks find that once you give them keys to the kingdom called Amazon, it's really hard to control them, like they're developers. So one guy shows up and goes, well, I want to use Lambda. Okay, great, go use it. Then it's like, oh, we're going to use API Gateway, and then we're going to spin a bunch of stuff into Lambda. So considering it's about 2.5 years ago, I think, we didn't really have any tooling to put around this. So we kind of put our heads together and go, okay, how do you help developers still move fast, but control what they're doing, at least in the sense of, does it go to production? If it goes to production, how do you tell the ops folks what's running? How do you monitor this? So one of the challenges we found with this setup was testing was relatively okay when it comes to Lambda, but the problem is Lambda actually has rate limits when it first started, so we were running into some of the rate limits. And you kind of go, oh, didn't know that. Don't want to find out in production, because when you run load testing, you may have pre-warmed your Amazon. So there are things you find out from a testing perspective. Interesting, I think serverless architecture didn't take off as much as we expected, but it still has a good amount of footprint. I think we were probably running about 10, 20%, but not as much as I thought. My guess was at least we would replace all the cron jobs that ever existed in our company with this, but I think that's a tall order. But generally speaking, for the 1.5 or the serverless engineering side, the challenges have been more around S3 buckets. I think some of you may or may not be aware, S3 had an outage about 6 months ago, I'd say, or probably 4 months ago, I can't remember. And what you realize is, because of that, you have production going out. And luckily for us, our engineering was good enough that we didn't take a hit on that day. But what we realized is when that happened, we had some caching issues, which surfaced a day later. So even though the S3 outage was that day, and we got pages, and people looked at it and go, nothing's going, everything looks good, come back the next day, find out you have some caching problems because you decided if something broke, you were going to cache everything in S3. So interesting behavior we found. So from that aspect, like I was talking about, we basically rely quite a bit on alert side. We use that quite heavily to help monitor our environments from how are we doing today? Does it look good? We use Sensu for graphing out all the physical layer stuff like your CPU, how are we doing from network connectivity perspective? We have App Dynamics for, generally speaking, Java, thread pools, that kind of stuff. A little bit of challenge because App Dynamics, doesn't really integrate well. I think now they've come out a long way in doing integrations better. We also have Splunk for logging. I think somebody talked about Elk. I mean, for me, it's about the same. We just apparently paid enough money, so it's not worth changing now. We alert everything to HipChat, email, and VictorOps. I think now it's kind of somewhere between VictorOps and PagerDuty. We have both. So it kind of gives you an idea of what we're doing. And I think we were using one of the earlier versions of AlertSite, I want to say. We're still using it, but in that version, it doesn't really manage the incident response. So we basically did what I would call a halfway between AlertSite and VictorOps to manage at least our alerts in production. Trying to see. So this is more of a generic slide just to show how we're doing it. So I want to give you a rough idea how we ended up. So we would call this like the 1.0 of our architecture, I suppose. On the data tier, we ended up with Mongo, some of it. Bulk of our NoSQL is Cassandra. We use quite a bit of Spark. We have Memcache as well, or Amazon's version of it. So from a mid-tier perspective, everything is basically run as a service in Java Tomcat. That's pretty much our standard. We have a lot of Node on the top layer from a UI or edge tier perspective, depending on if you're on a, if you go to Spectrum.net, which is the brand that Charter has for customers, if you log in to pay your bill, you want to watch TV online, you would technically use, the UI tier. At least from a routing perspective, we use Route 53 quite heavily, and the ELB tier. So to give you an idea, we are running about, I think at the end, we were running about 20 some odd apps on top of this stack. About a year and a half ago, I think that's where we would call the 1.0 complete, I would say. So on to the fun stuff, right? Like, so obviously people are not happy. You're running all this great infrastructure, and then it's like, what have you done for me lately? Well, not a whole lot. I still like the email that I got from my boss, which says, so, I noticed we had a presentation with another, platform company like Google, shows up and goes, hey, you could lower your CPU, but you can keep the same memory. We offer that. We're all elastic. Then the second question that comes out next day is, so what's our CPU usage? Geez, about 10% maybe if you're lucky, because we're running memory-intensive applications, right? We're not a CPU-intensive data, I would say. You could tweak them. You can only tweak so much, because if the machine types are not flexible, you can't tweak that. So obviously, that leads into there's this new hot stuff called containers. We want to do this. That's what the developers want. But you need a use case, and there's the use case, which is how can we help run better usage, right? So from that aspect, we started exploring containers. I'll dive a little deeper here. So the picture is more of the continuous integration of what we have done so far. Generally speaking, we've played with enough POCs, and we've come to the agreement that Docker seems to be pretty stable. Open Container Initiative is a good question. I don't know where that will end up from a community perspective. Kubernetes is, I think, by far the winner. We made that choice about a year and a half ago. I think we've not regretted that, and I see the market trending towards Kubernetes, which is really good. One of the fundamental things that we decided is, as part of the container initiative, we would be cloud neutral or cloud agnostic. If you noticed in the Lambda architecture phase, on 1.5, we were kind of very heavily Amazon oriented, which is not a bad thing. It's just from a services perspective, would it make sense? Can you move faster? Can you move to a different cloud provider? I think those are answers. We decided we should go, yes, how can we do that? So some of that helps, because we picked Artifactory. For those of you who are familiar with them, we have Nexus as well, but we picked Artifactory because of their distributed model. Kind of helps with the next generation of the CI. A fundamental problem we never solved in version 1.0 was we solved the continuous integration problem. We never solved the continuous deployment model, because operations, like I told you guys, from an enterprise perspective, they're still, I will call them conservative. I wouldn't call them any different than that, because they're judged on what's the uptime. Are you doing well? Why did it break? I think that's the fundamental question that gets asked. Nobody's going to ask you, did you fix it? Or, because they know you'll go fix it, and it's going to happen some other time. So this second question that comes is, how will you make sure it doesn't break again? So it's a very tricky question when you're sitting in ops and you may not have all the insight from an engineering perspective. So in this picture, what you notice is, we talked about moving away from Jenkins. We leveraged Jenkins quite heavily, but they came out with a 2.0, I think. Trying to think of the number, but continuous delivery is something that came out as a pipeline process from a Jenkins perspective about a year and a half ago, I think, roughly. So we decided to leverage that and see how we could push to production. We've had an app running in, I'd say, production with this new infrastructure for about 6+ months, and we're doing pretty good, I would say. No outages on this, mostly because the pods actually have self-healing the way we built them. So we have another additional layer of actually being able to control the reliability, I would say. So from this picture perspective, the biggest challenge for us has been autoscaling works great, both on AMI and Kubernetes. But generally, you'll notice Game of Thrones is always at the same time on Sunday. And that means people may record stuff. And that means you'll have a flood. You won't have a linear scale when you try to autoscale. Autoscaling still has challenges in the sense of how long does it take to autoscale. AWS has rate limiting. It still takes you about 60 seconds, which now sounds really bad. You can imagine 5 years ago if somebody said, yeah, the new machine will spin up 60 seconds. I think we would have said, great, that's the best news you've told me all day. And now it's like, 60 seconds, too slow. Like, I need something now. So generally speaking, that's still one of the challenges when you have a flood from an incoming, what I would call requests perspective. I think we still have some challenges there to solve. Right now, we're running in a hybrid stage, which is we have half of the Netflix OSS architecture still built in. We also have a foot out of the door, a foot into the new door, which is called Docker containers. Some of the challenges we have from this aspect is, how do we take this and make this a lot easier when you deploy into production? So we kind of went with the concept of sidecars. I think This audience seems fairly technical, and generally speaking, if I asked how many people knew containers, most of the people might say, yes, we know sidecars. May or may not be the thing most people have touched. So we made some choices, which is as a developer, what should the developer write? Developers should be good at writing their code, which is Java. They shouldn't have to worry about third-party client libraries. So for those of you who have worked with Netflix or who've seen the Netflix model, what you got is a lot of client-side libraries being asked to integrate to make it work for you, right? It's like, hey, do this integration in Java. If you're in JavaScript, they have this. You need to integrate a client-side. What I would call library, which is still not the fastest way for a developer to move. So we tried to abstract out all of that, and the idea is you run services. Everything else is provided by the platform. Security, Vault. It's a HashiCorp tool we kind of picked up because it's pretty good at managing keys and making sure, if you have to still authenticate to some of the services. But generally speaking, everything is based on this architecture of developers are good at writing code. How can we help them move faster? And one of the challenges, and I talked to SmartBear about this, is so we believe testing is a service at this point. So all the testing you write from an API perspective needs to be baked into that node, right, into that actual cluster. So I think this is a discussion I was just having with somebody, which is, how can you help us do this? Because we don't want it to run as an outside service. It runs 10 API calls, it passes, only then we want to put it in service. I think discovery only does basics, like, you have a heartbeat, you look good, I'll put you in production. But we've realized sometimes it doesn't always add up. So we want to run a series of 5 to 10 small tests and say, hey, that worked. Let's put that in production. So I think that's one area we haven't really solved that. We're still kind of looking at the security perspective. So the way we envision is about a dozen sidecars. Depending on the app, they'll use some, they may not use some. As you can see, it's a big mess. This is what we consider the 2.0 of our close to model, I think. On the bottom, there's a lot of Kafka, so all the queuing. I can't remember, I think it was somebody in the morning said, ESB, and I kind of smiled because everything goes back to enterprise service bus at the end of the day. I think Kafka is just a lot smarter. It does it a lot cleaner. But we basically, I think we'll end up relying on Kafka quite a bit from a pipe perspective. We have a lot of Mongo in there, mostly because consistency from Cassandra perspective is different. So for the platform, we've made a choice to probably move to Mongo. On the sidecars, you'll see a lot of caching. The goal is service the API faster. Kind of, comes back to the question I was asking somebody this morning. I don't know if everybody was here, but they talked about API gateways and GraphQL and how does it fit in? Because when you ask for, give me all the movies from our perspective in our business, we go, yeah, there's like 50,000 movies that you as a customer have access to. That's going to 100K. That's a lot of payload coming back. So that's pretty ugly, actually, when you look at it from some clients' perspective. Some clients are able to handle it. Apple's OK. Android, some of the memory challenged phones are actually going to have issues. So we talk about how do you chunk that? How do you give responses that make sense based on the client? Or do you let the client say, hey, I want a very specific delineation. That means we have to create all these categories before. That means people have to curate this content, which we do. And there's genres. And you can say, hey, give me all the HBO series. It's a little bit easier, but it's still returning about 500 to 800 assets. And if the customer's watching on an Android or iPhone, you want to show that in about a second. I think roughly a second is too long now. Somebody did a UI test in the company, and they said 500 to 800 milliseconds is the preferred timing, which makes sense. Before you blink, they want to be able to show you what you asked for. So generally, those are the kind of challenges that we're looking at right now. And I think the gateway, GraphQL, some of the stuff that makes sense, we don't really have answers to that yet. We're also walking away from, I would say, majority of the Netflix OSS, switching more to a standard Nginx, as a gateway, with a lot of Kubernetes underneath. So let's see. Kind of gives you an idea of what we're running today. So like I mentioned at the beginning of the talk, 4.5 years ago, pretty much all the numbers were outsourced. or 0, right? We're running about 150 apps today. About a dozen are big, about a couple dozen are medium-sized, the rest are small. They serve different purposes. The number of systems is mind-boggling, I think. The instances, and this is just a dev and test, this is not production. Production scale is quite different. So it gives you an idea like, if you're a new developer, you want to go spin up your own environment, great, here's what you get. You're a new tester, you're testing a specific feature, but you need to go spin up X, Y, or Z, go for it. Comes at a cost, a slightly different challenge when it comes to accounting, but generally speaking, developer-oriented environments, I think, come at a little bit more cost than what I would call from a flexibility perspective. They're not as accounting or cost-friendly. So 500 plus releases, I think, is what we're seeing right now on a given day. Kind of gives you an idea. I think it's close to 1,000, but I think for safety reasons, I only put 500 because I wasn't really sure where we are today. So 75,000 builds. And so think of it from this perspective. Charter is still a very enterprise company. And to put this in place, it takes a lot because we're not used to shipping software as fast as some of the other giants are. But I think we're getting very close. And if you look at the number of tests, and that's where a lot of the testing is done, which is how do you make sure all these tests run all the time, right? Or at least on a schedule when they need to run in production, in dev, and make sure all this is aggregated. So we use AlertSite quite a bit on that, from a production monitoring perspective. So it kind of gives you an idea where we are.